Hey guys, I am going to do a short tutorial video on how to use algebra tiles. Those of you that had me in class last year, we did use algebra tiles, but this could be a good refresher. And my current juniors, we did not use algebra tiles when you were a freshman, but they actually are really helpful and kind of create more of a visual. We will be working with algebra tiles today in our lesson, and there is a virtual tool for you, or you can just draw them on a piece of paper. But in case you don't love them, don't worry. I just want you to kind of get a feel for them. And we are going to look at another method for completing the square today. But this is just one method that we will also dig into. So before we get into that, I do want to show you how these work. So I have three different tiles here, and I drew on them so you can see what they are. So the squared, the area of this is x squared. That means that the length of like one side is x and the other length is x, which makes sense because x times x is x squared. We also have these tiles, which are all my just plain x's. Those again have the length of x because they are the same length here, but then they have a width of the value of 1. So a width of 1. And then the last type of tile we have are our ones. And these are a 1 by 1. So the area of this is 1. So basically the x squared tiles account for the x squared terms in front. The x's are the number of tiles in the middle. And then the ones are my value here at the end. So basically what we're going to do is I'm going to represent this trinomial as a set of two binomials using algebra tiles. Okay, so let me do this on my next page. Okay, so the problem we had was x squared plus 7x plus 12. Okay, so that tells me I need one x squared tile, so I've got that here. I need 7 x tiles, so let me count those out. I think I have 7 right here. 7, okay, and then I need 12 one tiles. So I've got 2, 4, 6, 8, 10, 11. My cat knocked one on the floor. Here's 12. Okay, so we have to arrange these in a rectangle or a square so that we use all of these tiles. This is how this works. The way that I always do it is I start in the top corner with my x squared. Okay, and then I take my other corner and I have 12. So I could do 6 by 2. So we'll try that. If I do a 6 by 2. They're not going to be a perfect rectangle, but you'll get the gist. Okay, so if I did 6 by 2, then I would have to fill in like my x squareds. And if I did that, or excuse me, fill in my x's. Okay, so if I did it like this, I could see that this doesn't make a whole rectangle. So that means that I need to use a different factor in the bottom corner than 6 and 2. Okay, so another factor that we could use is 3 and 4. And 3 and 4 makes sense, obviously, because 3 and 4 would give me my 7 here. So what I'm going to do is make this down here a 3 by 4 instead. Okay, and then I'm going to put 4 of my x's here. And then my other 3 will go over here. And as you can see now, once I have them together, it's a little sloppy, but you can still get the gist that we have this nice rectangle piece here that all fits together. There are no gaps anywhere. So that tells me I'm in the right place. And now the way that we can use this to help us find what the two binomials are, because we obviously have to make a binomial times a binomial to help us factor. So what we will do is we will look at what the columns and rows have in common. So for example, if I have x squared, x, 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 the GCF of all of these would be an x. So that's what I put here. And same in this direction. And this kind of like actually mirrors our box method, right? So if I did the box method here, My top corner would have the x squared. I would have 4x, 3x, and 12. And then I could start to find what's in common. So for example, like I have x and x. Same thing goes here, okay? And then since I have x and a 1 and a 1, the only thing they would have in common is a 1. So each of these is a 1. So that turns into x plus 1, 2, 3, 4. So it's x plus 4, which again, sorry about my light here. Again, if I look at my general model, this would have been a 4 here, okay? And same on the side, these would all be 1s. So I have x plus 1, 2, 3, x plus 3. And same, this would have been a 3. So basically the algebra tiles, those are what create an area model. So it's a little bit more visual, and that's how we initially teach factoring in the 9th grade curriculum now. Most of my juniors, you all learned it this way, okay? And we will continue to use this idea, but for today's purposes, we are going to dig into the algebra tiles because we're going to be talking about completing the square. And I actually really like completing the square with the algebra tiles better than with this general method here, but we are going to look into both. And like I said, I taught all of you completing the square already, but it was something that we briefly went over. So we're going to dig a little bit deeper into it today and kind of see how it's going to be really helpful for us. So in my next video, you will see how I will use the algebra tiles to do completing the square.